Hey guys, so today we're going to do our lesson on symmetry, and the first half of this should be very familiar to you, talking about line symmetry, and then we're going to do rotation symmetry, which I think is going to be new for most of you. Okay, so lines of symmetry are just lines that divide a shape into two congruent halves, and by congruent we just mean that the two halves are going to be the same size and the same shape. With line symmetry, those congruent halves will also always be mirror images of each other. So you could reflect one half and it will land on top of the other half. So for example, a heart has one line of symmetry right down the middle. The two halves are mirror images of each other. This kind of lightning boltish shape has no lines of symmetry. There is no way that I could divide this and then flip a point over the line of symmetry and it land on like a matching point. This little star here, let's figure out how many lines of symmetry it has. So I can go from point to point straight through, and I can do that with all of the points, like so. So right now I have 3 lines of symmetry, 1, 2, 3, but I can also go from like little indent to the opposite little indent. So 1, 2, 3. So I've got 3 lines of symmetry that go from point to opposite point, and then 3 lines of symmetry that go from indent to opposite indent. So a total of 6 lines of symmetry. Now, anytime you have a regular polygon, and by regular polygon, we mean a polygon where all of the sides are the same length, regular polygons will always have the same number of lines of symmetry as their number of sides. So that means that a square should have 4 lines of symmetry, a triangle, at least an equilateral triangle, should have 3, a hexagon where all the sides are the same length should have 6, pentagon would have 5. And the reason for that is if we look at this square here, I can go from corner to opposite corner, like so, or side to middle of opposite side, like so. So I have 1, 2, 3, 4 lines of symmetry. With my triangle, I can just go from point to the middle of the opposite side. So 1, 2, 3. And then with my hexagon, I can go from point to opposite point and get 3, and then go from the middle of a side to the middle of the opposite side. That gets me 3 more. So that's where the 6 lines come from. Notice that that rule only works for regular polygons, so only if the polygons all have the same length side. So for example, a rectangle is a polygon, but it is an irregular polygon. So it's not going to have 4 lines of symmetry. In fact, it will only have 2. I can go from the middle of a side to the middle of the opposite side, but I cannot go from corner to corner. And the reason for that is if I went corner to corner and then I tried to flip this point across that line of symmetry, that point would end up like here, not on the opposite corner. And you can demonstrate this if you take a rectangular piece of paper. So I have a sticky note here. And if I were to take this and try and split this in half or fold it in half, corner to corner, kind of roughly like that, as you can see, the 2 halves of this are not mirror images. I can't reflect them on top of each other. Okay. Whereas if I had a square, I don't know how perfectly square this is, but if I had a square and I tried to go from corner to corner, my two halves of my square line up perfectly on top of each other. Okay. Same thing with our triangle. Because this is an isosceles triangle, it's not going to have 3 lines of symmetry. Instead, this one is actually only going to have 1. That's the only way that I can split it, where the two halves will fold on top of each other if I fold them across that line. If I try and fold this any other way, that's not going to create 2 mirror images. So if you are trying to figure out how many lines of symmetry there are, you're just going to cut the shape into 2 mirrored halves as many times as possible. And you'll just keep doing that until you run out of lines that you could draw. If you needed to draw a symmetrical object, usually you're going to be given half of the object, and then you're just going to reflect it over the line of symmetry in order to draw the other half. So you're just kind of creating a mirror image. So for example, if I had a line of symmetry like so, and then I had an object that looked like let's say that. In order to reflect this, I'm just going to take each point and move it the same distance away from the line of symmetry, but on the other side. So this point here needs to be about that far away, but on the other side. And then this point is, again, these should be about equal distances away. This point and the point I'm about to draw should be about equal distances away. And then we just connect the dots. And I now have a symmetrical object. Okay, the other type of symmetry is something called rotation symmetry. And this is anytime an object can be rotated less than 360 degrees, so less than the full way around, and still be identical to the original. So for example, we go back to our Post-it notes for a second, or just any rectangle. Right now I've got the long side on the top and the bottom, the short sides on either side. If I rotate this 90 degrees, it doesn't look the same. Now I've got the long sides on the side. But if I rotate it another 90 degrees, now it looks identical to the original. So I've rotated 180 degrees from the original position, and it looks the same as the original. So this stack of Post-it notes has rotation symmetry because I haven't rotated it a full 360, and yet it still looks the same, even if I only rotate it 180. The order of rotation is the number of times a shape looks identical to the original while I am rotating it 360 degrees around the center. So again, back to my rectangle of Post-it notes. If I'm rotating this around the center, right now, again, I've got my long sides, top and bottom. As I rotate this, I've gone 90 degrees, hasn't looked the same yet. But if I get to 180 degrees, now it looks the same. So that is 1 order of rotation so far. And then if I keep going so that I get a full 360, then it looks identical at 360. So that counts as 2. So a rectangle will have an order of rotation of 2. During a full 360 degree rotation, it is going to look identical twice. So if we look at a square, that is going to have an order of rotation of 4, because I can set the square on any one of these sides, and it is going to look the same, regardless of which side I stand this square on. So as I rotate this a full 360, it could stand here, or here, or here, or here. 1, 2, 3, 4 places it could stand where it would look the exact same. This diamond shape, on the other hand, let me see if Can I make a diamond? I don't know how to make a diamond. If we have this kind of diamond shape here, as I rotate this around, right now, doesn't look the same, doesn't look the same. Now it looks the same again. So that is an order of 1. And then I keep going until, oh, sorry, I'm off the screen now, until I get back to the original. And then it'll look the same again. Okay, let me just kind of draw that out bigger. Okay, so diamond, it's like stretched long ways. As I'm rotating it around, it looks the same now, so that's 1. And then back to the original position, that's 2. So it's going to have an order of rotation of 2. Essentially, it could stand on this point or the top point and still look the same. Therefore, it has an order of rotation of 2. The angle of rotation is the minimum distance a shape has to rotate in order to match the original. And the way that we calculate the angle of rotation is first we find the order of rotation, and then we just do 360 divided by the order. So for example, if we look at this regular pentagon here, it could stand on this side or this side or this side or this side or this side. Doesn't matter which side it stands on, it's going to look the exact same. Okay, and the way you could tell is just that's going to look the same as that, as that, as that, as that, okay? So it doesn't matter which of these sides is on the bottom, it's going to look the same. So an order of rotation of 5, and then to find the angle of rotation, we just do 360 degrees divided by 5, which is 72. So pause for a second, see if you can figure out what that star would have as both an order of rotation and an angle of rotation. So for your order of rotation, you should get 6 as your answer. Essentially right now, I would say it's like standing on that point, or that point is at the bottom, but I could put any of these points at the bottom and this star would look the exact same. And since it has 6 points, and any of those could be at the bottom, it has an order of rotation of 6. And then to find the angle of rotation, I just do 360 degrees divided by 6, which is 60 degrees. Essentially what that means is to get from one point to the next, it's moving over by 60 degrees. Okay, next up I have given you a rectangle, so tell me what would its angle of rotation be? So this time, because the order of rotation is 2, because it could sit on this long side or this long side and be identical, I just do 360 divided by 2, gets me an angle of rotation of 180 degrees. If you need to draw a shape that has rotation symmetry, just take any shape. In this case, I started with a diamond, and then pick one of the vertices, so one of the corners, and rotate the shape around that vertice, drawing it in every 90 degrees or 180 degrees or every 60 degrees. Just pick a degree and every that amount, draw in the shape. So in this case, I have decided that every 90 degrees, I am going to draw in the shape again. So I did it at 90 degrees, and then 90 degrees later at 180, and then 90 degrees later at 270, and then I got back to my original. Okay, that is it for today's lesson.